All right, we have one more video here on complex numbers, and we're going to look at division of complex numbers. And again, this section, I love OpenStax and all the free stuff, and college algebra. This book is a little thin, again, on examples. So I'll take you through what we've got here. It's the same concept every time, so hopefully that's enough. But if you need more, I'll try to make supplementals. So here's the idea. Well, the first thing is it works exactly like rationalizing a denominator. Do you remember that if you had, well, I'll show you this. So remember, if you had the square root of 2, we don't want to do division like this. We don't want to divide by a radical. So what we would do is we would do this. Multiply the top and the bottom by the square root of 2. Well, do you remember what we would do here? If I wanted to get rid of a radical here, square root of 2 is not good enough. What I needed to do is I would do something called the conjugate. I would multiply by 1 plus the square root of 2 on both the top and the bottom. And the reason was, it was a clever trick that if I choose those opposite signs, it would get rid of all the roots. That is exactly what's happening here when we divide complex numbers. Now I'll show you that in a minute, but the first thing is, just like we did here, we need to know what the conjugate is. But here it's a complex conjugate because we have a complex number. Its conjugate is going to be the same number, except with a different sign in front of the imaginary portion. So here's what I mean. The conjugate for this would be 2 minus, now they've written that in kind of a weird way, but 2 minus I square root of 5. And the conjugate for this, well, this doesn't have a real portion. It just has the imaginary, so it would be 1/2 I. Or 5 minus 3i. Its complex conjugate would be 5 plus 3i. We're keeping everything the same and just changing the sign in the middle. Okay, so same idea here. The complex conjugate, everything's going to stay the same, but we're going to change it from addition to subtraction. Okay, now this is where it's unfortunate that this is all I've got for you here. Again, I can try to make you something else, but here's what we've got. 2 plus 5i divided by 4 minus I. Now here's the concept. We're going to multiply the top and the bottom by the complex conjugate, just exactly the way that we did when we were rationalizing a denominator. It's literally the exact same trick. Now, here's why we're doing it. Now, we're going to have to FOIL both the top and the bottom out, but look what happens when we do the bottom. I'm going to bring this over here and show you. So when I FOIL this out, here's what's going to happen. I'm going to get 16. I'm going to get positive 4i. Now, start to FOIL this out. I get negative 4i. And here times here, I'm going to get negative I squared. Now, why is this helpful? Because just the same trick as what happened when we did it with square roots, those are gone. The middle will drop out. And look here, you say, well, we've got I squared. Well, we know what I squared is. I squared is negative 1. So here's what I'm going to do. I squared is negative 1, so I have that negative negative, but this is going to turn into 17. So all of this turned into a real number. So let's do the top now. We're going to go here times here. I'd get 8. Here times there, give me 2i. Now 5i times 4 gets me 20i. 5i times another I is going to get me 5i squared. Remember we saw that in the last video? Now I'm going to finish tidying this up and I'm going to put it over the denominator. So I squared is going to be negative 1. All of this is negative 1. So do you see that all of this last term is turned into negative 5? Because the I squared is negative 1, 5 times negative 1 is negative 5. So this is going to be 3 plus 22i. Now, here's what's going to happen. When we did this with roots, what we saw was because we knew there would be no middle term, what you can do is just square the front, square the back, and give it a minus sign. That's exactly the same trick we would have done before because we knew there was no middle term. Well, we can do the same thing here. Now, just remember, I squared makes negative 1. So this is 3 plus 22i over 16 plus 1, because this is -1 and there's another negative. So I've got 3 plus 22i over 17. Do I want to say anything about that? So you could FOIL this out if you wanted to, and you'd get to the same place. You could do it a long way. If you don't see the shortcut that I'm getting at, it's going to get you to the same place. You're just going to realize the middle terms are always going to fall out. So the shortcut is square the front, square the back, give it a minus. It's the same exact principle that we'd see when we were rationalizing the denominator. The only difference is now I squared can be tidied up because we know that's -1. Now one last step here. This would be acceptable to me, but you can give this denominator, just like you would do if you were, suppose you had done a line. Suppose you were finding the slope-intercept form of a line and you divided both sides by 2. Remember, you could give that 2 to both pieces there, both terms, and make it 3/2 x plus 5 over 2. You can do the same here. You can make this 3 over 17 plus 22 over 17i. Now, this isn't all that helpful in this particular one. This would have been okay with me, but sometimes it's going to go in evenly. Like suppose it had been 2y equals 4x plus 6. When we divide by the 2, we would have got, y as 2x plus 3, because the 2 would have gone into both parts. Well, sometimes that can happen here and we get a nice tidier number. So again, the 17 can go to each if you want. Okay, now I'm sorry that's the only one, but again, I can make some supplemental videos if you need some more examples.